Alright, time for another DraftPhysics.com, DebatePhysics.com, also video presentation. Okay, number 5, part 5 in this story of atoms as told by whatever, the minister. It's just a religion. It's just a bunch of made up little stories, connected loosely in some sort of ugly Bible. And it really doesn't have anything to do with reality. 3 dimensions of space and stuff, material stuff being pushed around by stuff we might call a force. Anyway, they really don't get that part, physicists. Yeah, they're telling a completely different story. All right, so let's get to it and such. The wooey bits. Wooey wooey. Blah 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 blah. Blang 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 blang. Yeah, there's the music.
1912.
It's not as bad as last video, so at least they figured out how to turn the music volume down. So in 1912.
In a hot air balloon about 3 miles above the ground, an Austrian scientist called Victor Hess made one of the most astonishing discoveries in science. Up here, Hess found that incredibly mysterious rays of energy were pouring in from outer space and streaming through the Earth. They were incredibly powerful and yet unlike anything anyone had ever seen before. They were called cosmic rays.
So why couldn't they see them, if they're streaming through the Earth, right? So there's part of the story's already broken. So we can't even really describe it right. The reason why I have to go open the balloon to see them, okay, is because by the time they get to the Earth, they've been broken into a whole bunch of other kinds of rays. So what goes through the Earth is debatable. None of it goes through the Earth. So, that's just sort of bullshit. All right, so anyway, continuing.
At the same time, in laboratories down below, scientists were studying equally mysterious and equally powerful rays of energy pouring out from the interior of atoms, energy known as radioactivity. Mysterious rays from the vast emptiness of space and mysterious rays from deep within the atom,
Right, so this is in a 20-year period.
Tiniest building block. No one really understood what they were, let alone believe that they might be connected. Then an incredible story unfolded. Cosmic rays and radioactivity turned out to be connected in a way so shocking that it beggars belief.
All right, so everything's shocking and amazing and the most profound thing that ever happened and all of that crap. I probably should obscure him more, so I'll pause. All right, that's as good as it'll do.
The discovery of this connection would force us to rethink the nature of reality itself. The world we think we know, the solid, reassuring world of our senses, turns out to be just a tiny sliver of an infinitely weirder, more wonderful universe than we could have ever conceived of in our wildest fantasies.
So this is, what is all that? So I'm just going to make the counter argument that no, there's just electrons and protons and they're pushed around by what's called force. And they have an inverse relationship with the force, and that creates charge, and everything is just basically comes down to an electron does it first. The force does it to the electrons. The electrons make everything else happen because they're on the outside of the atoms, and so they're the bigger player. Clearly the protons have a role to play, don't get me wrong. Nucleuses do fall apart, and that's what this radiation is all part of. But it's all just electrons and protons, and you can make them move slow or you can make them move fast. You can make them move together. Neutron. All right, continuing.
Our reality is just an illusion.
Oh, so that it's just why say these kind of things? What why is that our perception of everything is an illusion in the sense that we're putting together light signals and creating an image of something, a model of it. We don't even see the stars as they are, we see them as they were. So it's an illusion. Okay, so, but it doesn't matter. The argument is the model we're receiving coherent to the reality. And yes, I would argue that the photons are doing us very well. They're showing us, that you have 5 fingers and all of that kind of stuff. So it's working pretty damn good.
In the years up to the mid-1920s, the atom revealed its strange secrets to us at a prodigious rate, as it produced one scientific revolution after another.
Look, the 100 years from, you could go through 300 years from Newton on. The 1700s pretty dull, but the 1800s on, lots of stuff. All this magnetism, electricity, all that kind of stuff got, better teased out. But they made huge mistakes. Wave particle, and that goes all the way back to Newton. And obviously the kinetic energy thing is just such a farce.
In 1897, Marie Curie studied strange rays pouring out of some rare metals. She called them radioactivity.
So again, she didn't really, she might have coined the phrase, but obviously she didn't make the discovery, so that's a little bit of a deception. It just isn't accurate.
Then, in 1905, Albert Einstein conclusively proved the existence and size of...
So he says it again, okay, because that's what he said in the other video, right? The stupid pollen thing. It's just an observation, and it would be just as easy for a naysayer to say, well, the pollen is bouncing because there's waves on the surface of the water. It's just waves. It's, you don't need atoms.
An atom by studying the way pollen moves in water. A few years later, the New Zealander Ernest Rutherford performed an experiment in Manchester that revealed to him the shape of the interior of an atom.
So again, revealed to him the shape of the interior of the atom. All he got back was a reflection of a piece of crap. So he threw crap at something. Most of the stuff went straight through. One piece of crap comes back, indicating some idea of what the shape is, but it doesn't really tell you that much. And again, they just drew more and more assumptions based on the very thin evidence. They didn't have enough to start saying how big nucleuses are because they don't know the circumstances that cause the reflection. Again, it might require that the object, the atom, the nucleus it's hitting has to be in motion, and it has to actually be moving against the direction of the radioactive particle for there to be a reflection. It just might be a fact. So obviously it's not as rare as it looks, because it's more about the motion of the atom than the existence of the atom.
Scientists were shocked to discover that the atom is almost entirely empty space.
So the question that brings up is, if you're going to make that argument, then how do photons ever, create a coherent reflection? Because they have to be hitting atoms within the same distance in the material, or the frequency is going to get all way out of whack. So a lot of this just doesn't really fit, that it's as empty as they claim it to be, because then you would have to go an awful lot of atoms deep to actually hit something. And it seems kind of obvious, frankly, that there are real hard surfaces and things reflect off the surface, not, halfway through the surface.
The question then became, how could this empty atom possibly make the solid world around us? The answer to that was worked out by a group of revolutionary physicists in Denmark.
So this is where the wooicists took over.
They proposed that the world of the atom ran on principles which were completely different to any mankind had ever seen before.
So whatever that means. Well, we never saw this new Holy Ghost. So we have to come up with some new word, the Holy Hobgoblin. Yeah, we never saw a Holy Hobgoblin. Yeah, that's all new to me. Yeah, the Holy Hobgoblin. And its helper pixies.
It meant that the atom, the basic building block of everything in the universe, was unique, and perhaps...
What does that even mean? Unique. It's just, it's just like, shit, it only comes in this 90 forms, and it has every appearance of being made out of exactly the same stuff and exactly the same configuration. Yeah. Okay, yes, the matter is the only matter in the universe. Oh, wait a minute. No, we invented dark matter, didn't we? So, yeah, it's not so unique after all. And we have antimatter. Oh, it's not so unique after all.
Outside human comprehension.
Oh, brother. No. It just, no, sorry. This is a religion.
Then, as scientists
I mean, we can understand push. You can, I can have this argument 600 times, but I mean, I mean, physicists are too smart to realize there's two concepts, pushing and pulling. And one of them makes an infinite amount of sense. Okay, happens all the time, the pushing, but the pull doesn't work.
explored the nucleus, the tiny heart of the atom, they found it bursting with powerful energy. This discovery gave them the potential to bring about the destruction of the Earth. But in a shocking turnaround, it also gave them a fundamental understanding of how the universe itself was created.
Oh, it's just such an uninteresting question. And they really aren't going to find the right answer, frankly. It was created by a dumbass. And it's made out of dumbass. It's not going to be some fancy explanation. It was trying to do this, and it did that instead. Yeah, that's not going to be the answer.
And yet, despite this, the journey to understand the strange and capricious atom had only just started.
So there's just no physics here at all yet, but okay, we'll hope.
In 1927, a young man was studying at the mathematics department of Cambridge University. Shy, awkward, clumsy, and frighteningly brilliant. His name...
So that's his opinion, of course. Okay, so this is going to be Dirac, right? It's going to be fucking Dirac. Whack job.
His name was Paul Adrien Maurice Dirac.
I mean, it's just so funny. I mean, he really didn't contribute anything but nonsense. Antimatter. Wavicles. I mean, nothing physical.
It's probably fair to say that Paul Dirac isn't a household name.
Thankfully.
He should be. He was recently voted by other physicists.
Yeah, by the loop-de-doos who believe in the holy hobgoblin.
As the second greatest English physicist of all time.
Brother.
Second only to Isaac Newton.
And he deserves the accolade.
Oh, why didn't you say Leibniz? Well, Leibniz wasn't English. But anyway. It's all such bullshit.
Brilliant minds that pioneered atomic physics were left trailing by Dirac.
Oh, I mean, just more blah, 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 blah. Show me an example of, how he made a nuclear-powered bicycle or something.
Aghast at the sheer boldness and lateral thinking in his work.
I believe Einstein thought he was full of shit, so we'll see.
When Einstein read a paper by the then 24-year-old Dirac, he said, "I have trouble with Dirac. This balancing on the dizzying path between genius and madness is awful."
Yes, it's pointless. That's what it is. It's mush. So this whole idea that they can create some mathematical abstraction that somehow defines this simple function of how electrons and protons interact when they interact by these simple rules dictated by charge. And we've all seen charge. We've seen balloons stick to the wall. We've seen what you can do with static electricity and creating charges on objects. That's all that's running anything. That's what atoms do all day long.
In 1927, for reasons no one has ever really fathomed, Paul Dirac set himself a task which was monumental in its scope: to unify science, to bring its scattered parts into one beautiful entity.
So you just mush. So obviously the trick is the bent space nonsense versus the quantum mechanics nonsense, and this is what you get. So when they try to force these things together, what does he invent? Magical antimatter that somehow, I don't know what does it do? Where is it? How can it function? If you put the positive charges on the outside of an atom, then that atom can't interact with light, and the light will actually penetrate and hit the nucleus and do all kinds of who knows what. The two things can't exist in the same universe.
And what this meant, above all, was to unite the two most difficult and counterintuitive ideas in history.
Here's what Dirac was trying to reconcile. First, there's quantum mechanics, a set of mathematical equations that describe the atom and its component parts. Then there's...
So it doesn't describe anything. It's just nonsense to say they described anything. They don't know what charge is. They invented a special force that pushes protons together when all you need is an electron between the two protons. I mean, it's all just rubbish and nonsense. The only part they got right is there's electrons and there's protons. And they got fooled by a neutron because they didn't think that, well, maybe that's just a dipole. And it's not going to move in a charged field if it's north-south in orientation. It's just going to plow through it.
Einstein's special theory of relativity, which at first glance seems completely unrelated to the atom.
E equals mc squared really isn't a relativity equation. So, put up his relativity equations, which are these monstrous, horrible, monstrosities.
It deals with loftier matters like the nature of space and time themselves. One of its consequences is that objects behave very differently when they travel close to the speed of light.
So this is, again, their assumption, okay, not anything based on anything called real evidence.
The first thing you might ask is, why would anyone want to reconcile two such different theories?
And again, what are you reconciling? They're both break the whole idea of continuity and conservation of energy. I mean, for example, gravity gives things momentum. The momentum crashes into the earth and then escapes as heat. So it's really just free heat. You've added energy to the universe because gravity didn't use any energy to give the thing energy, right? Because it's just bent space. It's just a bent geodesic. No energy was consumed to give the objects momentum. I mean, this is a lack of continuity, and the fact that they haven't really thought about any of this crap.
Well, by the late 1920s, the equations of quantum mechanics were consistently getting the wrong answers when describing electrons, one of the constituents of atoms, as they move at very high speed.
So this is the catch, is that you're almost saying, who cares? Right? They talk about how it falls apart when describing the first millisecond of the Big Bang, or it falls apart when describing, the last moments of a black hole's, suckification. I'd almost say, who cares if it fails then? I think it fails right from the very beginning. It doesn't fail in these abstractions. It fails to get anything right. These people, again, can't draw a two-slit experiment pattern correctly to save their lives. They can't even admit that they've never dropped 4 pounds 1 foot and 1 pound 4 feet. They claim it's the same energy. They've never even done the 25 times the fuel. They've never even taken their car out of the garage and poured 25 times the fuel into it and then drove 5 times as fast and see if they can use all that fuel. They haven't done anything relevant to physics. All they've done is knit little hats to wear.
But for Dirac, there was a much more esoteric motivation. He was once quoted as saying that a physical theory must have mathematical beauty.
So again, it just, the math isn't the thing, okay? You can't describe 2 bowling pins by just saying 2. It doesn't say anything, okay? So math is always going to fall way short. It's It's a shortcut formalization, okay? It's not describing reality. Reality isn't math. Reality is geometry, and that's math.
So for him, the fact that quantum mechanics and relativity weren't reconciled wasn't just inconvenient, it was downright ugly.
Yeah, and it's downright stupid because you already surmised that gravity is probably moving the same speed as all the other forces. You know, light, magnetism, gravity, these are all things moving this speed of force. So you should be able to figure out that, yeah, whatever it is, it's all made out of the same crap. This force stuff. The invisible stuff causing motion. And it's not entirely invisible, obviously. I suppose it is. I mean, light is invisible unless you terminate it. Gravity is invisible until you terminate it, right? You don't know, you know. I guess you could detect your motion, okay? So you can detect the fact that you have motion relative to something, but you can't really be sure until you actually hit something, whether you are the one collecting momentum.
So around 1925 in Cambridge, Dirac put his extraordinary mind, a mind that even Einstein had trouble keeping up with.
Okay, so again, they're implying that Einstein had trouble keeping up with it, and other physicists would tell you, Einstein knew what he was talking about when it came to all these theories. All right, and the fact is, Einstein found it. It doesn't clarify; it dirtifies. Okay, it makes it dirtier, not clearer. It's smudging the windshield. It isn't cleaning it.
To work.
This is room A4 of New Court, and it was Dirac's original study.
So again, they go all the way to these places to do this. They couldn't even paint a fire on the fireplace.
The original fireplace has been boarded up now. But it was here that Dirac tried to understand and bring together the two new ideas of 20th century physics. Now, word is Dirac would sit here in front of his blazing fireplace and try and understand and bring together these two different theories into one unified picture, one single equation.
So, they could just put a little dummy in the couch and they could paint a little fire on the wood and, make it look a little more realistic. But no. Oh, sorry, you can't see any of that anyway. But whatever. The point, there's a couch in an empty room, so there's no table to even put a piece of coffee on or something. So how the hell did he actually do all this there? But anyway, let's just continue.
For 3 frustrating years, he laboured alone on the problem. Then, one evening in early 1928, he had an amazing revelation.
The only way I can explain what happened is to say that the equations of quantum mechanics and special relativity coalesced inside Dirac's mind.
So this is just talk. I mean, it's just the physicists today are still arguing because the two things really aren't compatible. It's just a fact. Bent space and bumping particles don't go together. The momentum carriers of electromagnetism doesn't fit, okay, with bent space, free energy.
Einstein's description of space and time somehow stretched and squeezed the existing equations of the atom. They bent and twisted them into all sorts of new weird and wonderful shapes. Then, guided by his unshakable belief that nature's laws must be beautiful, Dirac honed in on one equation, an entirely new description of what goes on inside the atom.
It's really pointless to make these shows for a general audience, when you're going to do all this hype about something, no chance the general audience is going to have any idea why this is brilliant.
Dirac knew it was right because it had mathematical beauty.
Says him. So you really can't see it even in the original film because it's all blurry.
Here it is, the Dirac equation. Gamma mu into I d mu minus E a mu psi equals m psi. Don't try and understand it, just...
Yeah, don't bother trying to do anything with this, but say, why don't you just cross this crap out, this psi crap? I mean, it's multiplied by both sides, so why don't you just cross it out?
Look at it and marvel. As far as human achievements go, it's up there with King Lear, Beethoven's Fifth, or The Origin of the Species.
Oh, brother. Which is grotesque exaggeration.
Because hidden in these symbols is the perfect description of how reality works at a fundamental level.
So yeah, I'm supposed to believe that because he says so. Okay. And there's nothing here. This is not going to predict a single meaningful thing ever. Ever.
It's the key to nature's secret code.
Again, key to nothing. It'll open no frickin' I see the light door. That won't happen. Because it's garbage, it's nonsense, it's silly bullshit. Antimatter.
With perfect mathematical elegance, Dirac's equation describes an atomic particle travelling at any speed, right up to the speed of light.
That much Dirac was expecting to achieve. But when he looked at his own equation more carefully, he noticed something breathtakingly revolutionary about it. He later said his equation knew more than he did. In essence, Dirac's equation was telling him that there's another universe we've never noticed before.
So, obviously they haven't explained how this equation predicts this at all, how it can be manipulated to produce this result, why you wouldn't see it, obviously, if it's supposed to be integral to the formula. It should have been something you knew right away. Why did it take you a while to figure out? That's what it was saying. I mean, it's just such garbage.
That's because instead of his equation having one answer, it has two.
It doesn't have any answers. It's telling you this equals that. Okay? And the that has the same forky thing on both sides, which doesn't make much sense.
First describes the universe we know, made of the atoms we're familiar with. The second describes a kind of mirror image to our universe, made of atoms whose properties are somehow reversed. Now, science fiction fans will know what's coming. As well as matter, Dirac's equation predicts the existence of antimatter.
So it really just doesn't seem at all sensible. I just don't know why people fall for this, that, without really good evidence, you've got no reason to believe that this machine functioning could function with these opposite rule breakers.
Dirac's theory seemed to say that for everything in our known world, for every part of an atom, every particle, there can exist a corresponding antiparticle, with the same mass, but exactly opposite in every other way. And just like a world in a mirror, a universe made of antimatter atoms would look and work just like ours.
So it really wouldn't, because the force would have to be inverted also.
It would be perfectly possible for me to be made entirely out of antimatter. Anti-me would look and behave exactly the same as original me.
Right, but you couldn't shine light on anti-you without blowing up its nucleuses. Because now it has the force of the light is negative charged force, okay, electron force. And if the electron force is flying into the nucleus, and the nucleus is made out of gigantic big electrons, it's going to have a completely different effect than light affecting you. So you both can't live in the same universe with the same photons in it. The photons also have to reflect what you've done to the matter. So it's just nonsense, in my opinion, to make these claims, because charge proves the point. You cannot reverse the magnetic arrangement without consequence. It matters that there's more positive charge in the nucleus and negative charge on the outside. It makes a difference.
And indeed, it's possible that out there in the vast expanses of the cosmos, there are stars and planets and even living beings made out of antimatter. And there's one final prediction.
So again, it's just all this out of this piece of crap formula that didn't prove itself to predict anything. They all just like the story that goes with it. That's all this is about. They like the idea of the holy antimatter. You know, we have to come up with some other joke name for it, but I mean, it's just ridiculous.
Of the Dirac equation. As its punchline, it states that matter and antimatter must never come into contact, because if they do, they will annihilate each other in a fierce conflagration of pure energy.
So whatever even that means, where do they get the energy from? Yes, they're going to hit each other, but let's say they're going really slow. Where do they get the energy from? Where's this magical energy come from, and how does it escape? Where was it trapped, and what's releasing it? So yes, there's energy trapped in atoms, okay, in the sense that they do have an arrangement of electrons and protons that negate, okay, the pressure. And as soon as you eliminate one electron, then the two protons see each other and they repel. This is just this. Nothing can ever annihilate. So if you believe in conservation of energy and matter, the word annihilate isn't going to work. A Newton would hate this.
The combined mass of matter and antimatter would convert completely into energy, according to Einstein's famous equation, E equals mc squared. So, if I ever do meet my doppelganger...
All right, so E equals mc squared is, again, another piece of just unproven trite. Because the real point I would raise is that what we know is that there's a bunch of energy around us all the time. Cell phone calls, microwaves, sunlight, all kinds of energy hitting us all the time. And the simple truth is, if I have a box and I put that energy in the box and it just bounces around, it has more energy if I put a big round cannonball in the middle and consume half the space. Then the stuff that's left over is going to bounce around even more. It's going to hit every surface twice as often because of the matter's displacing space. So E equals mc squared is just telling you that mass takes up space in the universe, and by taking up space, you're confining how much space the force has to interact in. So if the force has less space to interact in, the force will have more energy. It will hit things more often.
We would explode with an energy equivalent to 1 million Hiroshima-sized atom bombs.
Oh, what a pile of crap. Oh, God, Jesus Christ. Anyway.
All this sounds like science fiction.
It sounds like crap-a-fiction. Crap, vomit-a-fiction.
And indeed, the idea of antimatter has inspired huge swathes of it. But the truth is, antimatter, particularly antimatter electrons called positrons, are made routinely now in laboratories.
So this isn't true, okay? They don't make them. They assume they exist, okay? That's all. They throw, protons at something, the something then creates positrons, and the positrons do something else, and then they collect the result of that thing. But they're just claiming the positrons are in the process somewhere. They don't make beams of positrons. It's just absolute, again, just they exaggerate everything and pervert it. So they call some kind of therapy, positron something. As if they're shooting positrons, and they're not. They're shooting regular protons at a radioactive substance they injected, and the radioactive substance they're claiming is making positrons.
Positrons are used in sophisticated medical imaging devices called PET scanners.
Yeah, they're not used, okay? They don't have any, there's no positrons, okay? They're just what they claim. So it's like calling it a quark gun. There's no such thing.
That can see through our skulls and accurately map pictures of our brains. But back in the 1920s, the initial reaction to Dirac's equation among physicists was deeply skeptical. Even Dirac himself had trouble believing his own...
Well, if it's so beautiful and it's so wonderful and it does so much, why were they skeptical? If it's just so obviously brilliant. Ugh.
results. Antimatter seemed such a preposterous concept. Then came resounding confirmation of the Dirac equation and all its paradoxical implications.
So even if you accepted the fact that, oh, okay, there we found a positron, that doesn't mean all the implications are also true. That you could actually make a human out of them. Oh, it's just such bullshit. Ugh. It's just so annoying that to talk about atoms, you have to talk about antimatter. I mean, it's just takes all the fun out of physics.
And it came from the most unexpected place, outer space.
In 1932, physicist Carl Anderson was working here at Caltech in Los Angeles when he made an amazing discovery. He'd been studying cosmic rays. These are high-energy subatomic particles that continuously bombard the Earth from outer space. To do this, he used a device called a cloud chamber. This is basically a vessel that's filled with a fine mist of water vapor. This shows up the tracks of the particles as they stream down through the vapor. And placed inside a magnetic field, these tracks will be deflected one way or the other, depending on the electric charge of the particle. So positive particles' tracks bend one way, negative the other. Anderson found evidence of particles that...
So obviously, see, the points that need to be made is that none of the, except for the neutron, all the other things that would have a charge don't have a complete charge. It's not a north-south charge. They're not perfect magnets. They have a whole bunch of slivers of north-south, north-south. So yeah, they can have more, red slivers than blue slivers, but it's not enough for them to turn. And so they won't turn and move because they don't have enough, there's not enough difference in their polarity. They have a difference in the polarity, but they don't have enough of a difference for you to get a big pile of motion out of them.
Look exactly like electrons, but which are deflected in the opposite direction. He had discovered Dirac's anti-electrons, particles of antimatter.
So we have nothing to show that. Okay, so the only example I see, like on a Wikipedia page, is they have some old 1960s picture of a track, and it spins down the wrong way to be an electron, but there's no evidence it's not a proton. And as I understand the historical record, the same experiment had been done years before, this was like the first, fourth, fifth version of it. And the guy just decided to call it a positron. The other guy says it's a proton. This guy calls it a positron, therefore it's a positron.
The Dirac equation is an impressive achievement. Its prediction of the existence of antimatter using abstract mathematics alone would be enough to make it a significant milestone in the history of human thought.
Just incomprehensible gobbledygook.
But within just a few years of publication, first Dirac and then others sensed that his new equation was telling them something profound, something completely new about nature. And they were right. But the revelation hidden within Dirac's equation...
Says him. So again, oh yeah, we're sure we're right. We have just about zero evidence, but we're sure we're right.
...would take the best efforts of the greatest minds 30 years to uncover.
The problem with Dirac's equation was this. Although it was incredibly powerful and had led to the discovery of antimatter, ultimately it could only describe a single electron. It fails completely to explain what happens when there is more than one electron present. What was needed was a new theory.
Doesn't even make any sense, right? That it was supposed to predict antimatter when it's only predicting what a single electron will do or something. So again, nobody's going to show us how this equation predicts anything or demonstrates anything or elucidates anything or makes anything more visible. So they're just going to say it does.
A theory which explains how electrons interact with each other. And that turned out to be the most difficult question of the mid-20th century.
So it's the simplest, when it comes to, it's just so simple to solve charge, okay? It's just 2 + 2 + 2. Two kinds of force, 2 kinds of matter, 3 kinds of interactions, absorption, reflection, and changing the nature of the little force bit. Changing an electron force into a proton force. So through that simple process, you can perfectly duplicate charge.
But when an answer came, it was to bring with it an unexpected revelation.
This office in Caltech, just outside Los Angeles, used to belong to the great Richard Feynman. In our story of so many geniuses...
Right, so this is his hero. All right, so again, I played Richard Feynman's lectures more than once. His two-slit analysis is laughably cartoonish. It's so bad. Doesn't really talk about the double maxima, doesn't talk about the more complex two-slit experiment that has two different patterns superimposed. It's just so amateurishly not connected to an actual physical real experiment. He even has the detector thing, that was never done.
Geniuses of science. Feynman stands, in my view, second only to Einstein in the list of greatest 20th century physicists.
Blah, 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 blah. So, I mean, where's Newton and Dirac in 20th century? Okay. So why isn't Dirac on the list?
You see, Feynman wasn't just a common or garden genius. Many referred to him as a magician. He was so smart.
Oh, this is like bishops talking about the Pope they just elected. Ugh, gross.
Such an innovative thinker. And like Einstein, he became this mythical figure, certainly a household name.
Yeah, for the cartoon, okay? Not for the physics.
Feynman was a larger-than-life character. He had a huge personality. He loved cultivating and telling anecdotes about himself. He used to frequent strip clubs. He had affairs with his students. He was even rumored to go to orgies.
So, I mean, having affairs with your students is pretty bad. It's kind of frowned upon. It's not rape, but it's it's rapey.
But his greatest contribution to physics was the part he played in developing the next phase of quantum mechanics.
The magical random god. So we have the holy hobgoblin, and now it's the magnificent randomizing mushmaker.
Feynman and his contemporaries were attempting to pick up the atomic torch from Paul Dirac and develop a theory that took our understanding of the atom literally a quantum leap further.
Oh, brother. It's had such exaggeration.
Like Dirac's antimatter equation before, the intention of the new theory was unification. They wanted to understand how electrons affect each other. In other words, it aimed to explain how everything works together through the electromagnetic field.
Push, 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 push. It's a push universe. They push on each other.
They called their unification project Quantum Electrodynamics, or QED. The project was a formidable challenge, but the end result was magnificent.
Says them again. So the end result is some wooey theory that if I have two slits, every single photon is randomized, but no, 97% of them go straight ahead, even though they all got randomized. So that part doesn't fit. All right, the pattern's supposed to be 180 degrees. No evidence it does any of that. The pattern runs out pretty quickly. The waves, the randomizer wave, is coming out of the middle of the slit, yet the math says you have to use, this distance or this distance. You can't use where the wave centers would be. So it's all farce and bullshit. Again, if you put two radio antennas opposing each other, so instead of shooting them the same way, they're shooting towards the same center, and then you just move the receiving antenna, you get the same interference pattern. The two signals never hit each other. They never interacted in space. They could never do any singularing. They could never do any superposition or entanglement. None of that could happen. And you get the same damn pattern. On off, the simplest pattern in the universe.
Nothing less than the most far-reaching and accurate scientific theory ever conceived.
Oh, just such hype. Bullshit, hype, nonsense.
For instance, it predicts a certain property of the electron called its magnetic moment.
So there's no such thing, okay? The electron can't have any properties except charge. That's the only property it has. It can't spin, it can't do anything funky, or none of the electrons would be all the same anymore. I mean, it's just such nonsense. It wouldn't matter if they carried spin, because then their momentum wouldn't be just their momentum, their velocity. It would matter, well, how fast was it spinning? And nobody asked that question. When it comes to hitting electrons into things, you don't ask, well, was it an electron that was spinning?
To have a value of 2.
So this is the thing. Yeah, so they do this experiment with a device. They know exactly what it does, and then they write a formula describing what the machine does, and then they reward each other saying how brilliant we are because our mathematical prediction of how the machine should work is equal to what the experiment produces, and it gets closer and closer the better we make the machine. So our formula is saying, the machine is sort of perfect. And slowly but surely, we're making the machine more and more perfect. And so the numbers match. That's miraculous. No, that's bullshit. That's circular crap.
0023193004. Experiments measure precisely the same number. That's an agreement.
Right. And they didn't at first, right? So they only had 3 places, 2 places, and then it was 3 digits, then it was 5 digits, then 7 digits, and then it's 49 digits. And it's only because, obviously, they start bending the formula to understand how the machine works, and then they figure out how the machine works and fix the machine. And all they do is force the 2 things to meet each other. Completely unmiraculous.
Between theory and experiment to 1 part in 10 billion. It's an unprecedented level of agreement. It's like measuring the distance between London and New York to within the thickness of a human hair.
And doesn't...
Quantum electrodynamics.
Mistake.
The thickness of a human hair.
The phenomenal accuracy of quantum electrodynamics shows it to underpin almost everything we experience in the physical world.
It's just such nonsense. Everything I experience? It's just so ridiculous.
It's as close to a theory of everything as we have ever come.
It defines the laws of nature at the atomic scale.
It's just none of this. It doesn't do any of this. It explains tiny little experimental manipulations. It doesn't go any further than that. It doesn't explain anything else. Because none of this crap they haven't figured out what a photon is, okay? Einstein was close to the truth when he talked about light quanta, okay? It's not a wave, it's force at a frequency.
Explains shape, color, texture, and the way almost everything interacts and fits together.
So it's just nonsense. It doesn't do any of that.
It underpins and encompasses everything from the biochemistry of life to why we don't fall through the floor.
So it doesn't do any of that. Charge tells you why we don't fall through the floor.
So what does QED actually say? Well, this is where the going gets very tough.
Yes. So it does all this explaining, except, you have to try to explain how it explains. Because its explanation is so ridiculously silly that, yes, you can't even explain it.
It may be a wonderful scientific description of nature, but trying to understand what Richard Feynman was doing with his theory is almost impossible. This is what he himself said when he introduced his theory to the public. It is my task to convince you not to turn away because you don't understand it. You see, my physics students don't understand it. That's because I don't understand it.
And look, it wasn't that complicated, okay? It's just showing the relationship. It's all just about phase. I mean, Feynman's little clock idea is all good. And what did the clock represent? Well, the clock just represented the phase changes, okay? So you're going from, it's just measuring the frequency at the speed of light. And you're just saying how many phase shifts did you go through as you travel through something. And that's, all that was perfectly sensible. But this idea that somehow, this is all incomprehensible, it's just nonsense. It's always about phase. It's just about the fact that yes, you'll if you have two photons, two pieces of a photon, and they're out of phase, they won't be a photon when they hit the surface. But if you have two pieces and they're in phase, that is, they're in the right sequence, then it will be a photon.
Nobody does.
If the inventor of the theory doesn't understand, what possible hope is there for the rest of us?
I mean, really, this is about, like, there's experiments. Newton's glass, okay? So Newton figured out you could polish glass and change how much light reflected. Now, Feynman's lecture on it is perfectly reasonable in some respects, but the respect that seems totally unreasonable is the fact that he doesn't realize the atoms, there can't be, the piece of glass can't have a half an atom anywhere. So on every bit of the thickness of the glass, it always has to be a full atom's worth of distance, right? So there might be 74 atoms, and then there's 96 atoms, and then there's 82 atoms, and, depending on how thick the surface is. And the whole point is that Newton would polish the glass, so you know that they're all probably pretty close. So it would be 80 and 79 and 81 and 78, and so it would be very close. And that's what's deciding. That's what the clock is figuring out, basically, is how many atoms thick is the piece of glass. So the bottom layer is telling you what the top layer is doing.
With that disclaimer, I'm going to try and explain anyway. First, you have to abandon your most basic intuition about nature. You have to give up the notion that empty space is empty.
So this is, no, I don't. I don't have to do any of that. I don't have to believe your religion, okay? I can live without your God and your Jebus and your Moses and your Job and all. I can do fine without it.
Let me try and explain. If I were to suck out all the air from this jar, you'd quite rightly say that having removed all the atoms, I'm left with a vacuum, a volume of pure emptiness.
The trick is, though, is that there's nothing to eject stuff, right? Like once when you're pulling stuff out, you need stuff to move to push the stuff out with. And once you've pulled everything out, you can't give anything that's left momentum. There's no way to do it because you're waiting for it to fall out. You're waiting for it to bounce around in its hot environment and accidentally walk into the container you're going to trap it in. And so there's stuff in that vessel that's stuck to the sides. It's stuck there, okay? It's going to stay there unless you heat it or do something to cause those bits to move. So you can only get the moving bits out. You can't get the pieces that aren't moving out. So technically you're still in trouble. And as soon as you decide to take the pump away, those little pieces will eventually pop into your vacuum.
Quantum electrodynamics flies in the face of this common sense idea by saying that the vacuum is not, I repeat, not a place where nothing exists and nothing happens.
So again, it's just why would I make that giant leap based on your say so? Because you really haven't shown so. You really can't show me so. You can't say it in any other words than saying Feynman says so. Well, Feynman says so isn't a good enough answer for me.
Instead, it's full of stuff and is heaving with activity.
So the truth is that obviously empty space is full of force, and you can't suck force out. So you're stuck with it. And that's the truth. Okay, so we don't have anything called empty space because there's always radio waves and light waves and gravity and all kinds of bits of crap flying through space.
How could this possibly be true? Well, let's imagine one tiny point in the emptiness. Common sense tells us there's nothing there. But quantum physics tells us there's only nothing there on average. And it's those two words, on average, that force us to rethink our understanding of reality. Think of empty space like a bank account, which on average has nothing in it.
So this has nothing to do with averages, right? You're not an average of the atmosphere. You're obviously a dense chunk of stuff. So this is just all such mush to sit there and say we are part of, some other system and we're not a clump. We're clearly a clump.
As a physics academic, this is a concept I'm very familiar with. Some days it might be £100 in credit, other days it might be £100 overdrawn, but on average it has a zero balance. Empty space turns out to have similar accounting skills, but it can borrow energy rather than money. And this energy is literally borrowed from the future, provided that it's paid back again.
All right, so this isn't even Feynman's real quantum electrodynamics. This is crap Feynman did later, where theoretically he proposed this idea that you could borrow energy from the future, use it, and as long as you gave it back to the future, it was okay. So it's sort of the gravity argument in some way, where somehow you can negate the fact that gravity gave something momentum, the momentum turned into real energy in the universe, and somehow that energy goes back in and creates gravity. And, and that's just so logical, right? That, okay, so now we've changed gravity into a real force. And so that's the game Feynman was playing, but he's only playing it because of the way we have created a universe where the energy isn't accounted for. And mv squared creates all kinds of exaggerated energies, and you have to account for where it goes, because it's not real. I mean, come on. This is all made out of virtual photons and nonsense.
Very quickly. In practice, what this means is that the borrowed energy can be used to create a particle and an antiparticle, which are spontaneously formed from the void, provided that a fraction of a second later, they annihilate each other and disappear.
So why should anybody believe that? Something spontaneous poofs, then it spontaneously poofs out. And for apparently absolutely no fucking reason. It doesn't do anything. It just poofs in and poofs out. I mean, it's just such crap. See, they're just looking for some way to contrive, some sort of argument against the fact that we're just all robots. They want to keep every indication is they're looking for something that gives them some hope that they can say they're not just a fucking goddamn machine. And no, the physics doesn't provide any of that hope. The real physics.
Energy is borrowed out of nowhere. It's turned into matter, the matter then self-destructs back into energy. And this happens in an
It didn't start as energy, or whatever.
instant all over the void. In fact, in a stunning confirmation of Dirac's antimatter theory, the vacuum seethes with huge numbers of matter and antimatter particles continually being created and annihilated.
So this is their nonsense. So this is like the empty space being just created. Space is just being poofed into existence. And it's making things look like they're moving away when they're not really moving away. It's just empty space is being created between them. So when the photon leaves, it has all this empty space it has to travel through. And so it takes twice as long to get anywhere because there's a bunch of poofy space being created, right? I mean, all doesn't make any sense at all. If it can be redshifted, then it's being slowed down. So then you have to recalculate your light years away thing because the photon took a lot longer to get to us. Because if you're stretching its frequency by making space, then the photon had to travel all that extra space. It's just too ridiculous, really. Too ridiculous. Too ridiculous. Alright, so that's probably halfway. Well, we'll do a little bit more.
Down at the smaller scale, space is a constant storm of creation and destruction.
Alright, says them. Okay, there's just no physical evidence of any of this crap. So I don't even know why this is a subject. It should just be something they do in their bathroom or something. This isn't something you do in public. Talk this complete bullshit. Alright, anyway. Enough. And so we'll finish it off next time and such. And so forth and whatnot. Fuck. Physics is pitifully silly.